Since chemistry is the study of matter, it seems appropriate that we talk about matter for a little bit. So we can classify matter based on its makeup or the physical state that it's found in. So let's talk about those physical states first. There's three main states of matter. You guys already know this. It's solid, liquid, and gas. So let's draw a solid sample in here. And we're going to make it a triangle. So there's 6 particles there. The solid particle spacing is very closely packed. There's not a lot of room between the particles. And the particle energy, well, they don't have a lot of energy. Okay, so they're very low energy particles because there's not any real movement. The implications of this, it's vibrational motion only. So if we could see down to the particle size, then we could see that those particles are vibrating. And they have a constant shape and volume. So it's one of the reasons I drew the solid as a triangle here, was to show that even though it's in a square box, it's still triangular shaped. Okay? So if we start to add energy to it, then we will take our solid and turn it into a liquid. And so it'll spread out, it'll fill the bottom of the container first. So, excuse me, the particle spacing is further apart, but it's still very close. Okay? And these will have higher energy than the solid. And the implications of this are that liquids are capable of flow. The molecules can kind of slide past each other. And liquids have constant volume, but take the shape of their container. So they don't have constant shape anymore. So this liquid's in the bottom of a square container, so it takes on kind of a square shape. If I moved it to a circular container, it would take on the circular shape. And then finally, if we add enough energy, we get the gas state. So at this point, these are the farthest apart. They fill up the whole container. And because of that, it doesn't mean there's more of it. There's lots of empty space between the particles. Okay? And so these have the highest energy of any of the particles. And so our gas particles are in constant random motion. It makes the gases become compressible, which means we can pressurize it and push the molecules back together to make it back into a liquid. And they have varying volume and shape. Okay. So again, that's most likely a review of things you've learned in the past. If we want to classify matter by its composition, there's 2 main categories. We have pure substances and mixtures. Pure substances cannot be broken down by physical means. Okay? So the 2 types of pure substances are elements and compounds. Get our definition in here for pure substances. So an element cannot be separated by chemical means either. And the best way to know if something is an element is to look at a periodic table. If it occupies a box on the periodic table, it's an element. So these are the simplest forms of pure substances. Compounds are chemically bonded elements. And so we can do chemical reactions that will separate the elements in a compound. Mixtures can be separated by physical means. And so what we mean by physical means would be filtration or boiling or things like that. There doesn't have to be a chemical reaction for a mixture to be separated. And so the two types of mixtures are homogeneous mixtures, which are also called solutions. They have uniform composition. So what we mean by uniform composition is it's the same throughout. When you look at a homogeneous mixture or a solution, you can't see the individual parts. So think about taking salt and dissolving it in water. It disappears. It basically looks like a glass of water still. A heterogeneous mixture will have varied composition, and so you can typically see the individual parts in a heterogeneous mixture. A lot of food examples for this. Think about a slice of supreme pizza or chicken noodle soup or, okay, this isn't food, but a mud puddle. Things that you can see the different parts in, and if you took a sample of it from a different place, it probably wouldn't have the same composition as another sample would. And then real briefly here, since chemistry is the study of matter and its changes, let's real briefly talk about physical and chemical properties and changes. So a physical property is one that can be observed without changing the identity of the sample. So these are going to be things like boiling point, freezing point, density, color, things that you can look at or measure and not change what you have. All right. Physical changes change the state of matter, but not the identity. Okay. So the best example for physical changes, those are your phase changes. So melting and freezing, that's the solid liquid change. Boiling and condensation, that's the liquid and gas change. And then sublimation and deposition, that's the solid and gas change without going through liquid. Any of those changes, you still have the same thing. If you think about a cube of ice, that's solid water. If you melt it, it's liquid water, but it's still water. If you heat it up, evaporate it, it becomes gaseous water, but it's still water. That's a physical change. You're not changing the composition of what you have, you're just changing the state it's in. Chemical properties are properties that have to be observed during a change. So they result in a new substance. This is going to be things like, does it react? Is it acidic? Is it capable of rusting? Is it capable of tarnishing? Anything that is an ability, okay, is going to be a chemical property. Chemical changes are ones that produce a new substance. So this is going to be our reactions. When we start talking about reactions, we're talking about chemical changes. And so one other quick difference in properties, we have extensive and intensive properties. Extensive depend on the amount of matter in a sample. So this is going to be things that you measure. So like mass, length, trying to think of another one, weight, which goes along with mass, but things that the more you have, the more the property is going to be. Intensive properties don't depend on the amount of matter in the sample, and so it's the same no matter. So density, the density of a substance, doesn't matter if you have a tiny amount or a large amount, it's the same density. Boiling point, water boils at 100 degrees Celsius, regardless if you have 10 milliliters or 1,000 milliliters. Freezing point, water freezes at 0 degrees Celsius. Same thing, doesn't matter how much there is. So an extensive property depends on the amount of substance that is present. Intensive does not.